I left you guys off with the basic principles or the basic concepts of energy. And now I'm going to show you how we track and analyze energy. And we do this through what's called LOL diagrams. All right, now you're probably like, whoa, what's the big deal? Well, they're not like they're funny or something. You're laughing out loud. This is just how we analyze things. You'll see why we call them LOLs in a second here. So I'm going to give you a situation where we have little Billy, all right? And Billy's going to have his action figure G.I. Joe. Snake Eyes, of course, he's the coolest one. And he's just going to have him go down this little slide he made. All right, look at that slide. That's a real slide, okay? So here's the table, all right, and he's just gonna go down the slide. Look, yeah, he's like, all right, way, he's going down the slide. But of course, he's got like swords because he's Snake Eyes. So he's got swords, you know. Snake Eyes is cool. All right, so anyways, he's just gonna have his action figure go down this little slide, and I guess we shouldn't make it floating. We'll put a ramp or something like that. All right, and so we just want to figure out, okay, what energies are present. All right, so a few things we want to keep track of, and that is just things we want to remember from our previous conversation, is energy is always conserved. S-S-E-R. There we go. There, brain. Good job, brain. Energy is always conserved, and work is the transfer energy between systems. All right, so we're going to keep these two things in mind while we do this, and we're going to analyze what's going on here. So, first thing we're going to do is we're going to draw an LOL diagram, and this is how we're going to track what's happening to Snake Eyes. All right. All right, so let's see. How many? 1, 2, 3, 4. All right, of course, I always do the first one's way too big. And I always run out of space, but here we go. I think this is what I want to do. All right, so first one's always way too big and off-centered. C'est la vie. So I wrote LOLOLOL. Okay, so thus the LOL. These are actually going to be bar graphs, and then this is going to be my system right here. So I'm going to have bar graph, system, bar graph, system, bar graph, system. And I'm going to analyze different points in time. All right, so let's change some colors here to make life more interesting. So I'm going to do part A will be, let's have Snake Eyes just sitting on the ground here. Okay, swords, gotta have swords. All right, he's just sitting on the ground, and then we'll do part B. He's at like the top of the ramp, and he's not moving. And then we'll say part C, he's partially down the ramp. All right, swords, okay. But now he's moving, so we have velocity, and we'll have part D down here. He's all the way at the bottom of the hill. All right, bottom of the hill, swords. Snake Eyes was the best, okay? And if you don't know that, then I'm sorry, but Snake Eyes was the most awesome of all the G.I. Joes. So, I don't even know what I'm talking about G.I. Joes. Anyways, so we're going to talk about 3 different points. So this is going to be point A, point B, point C, and point D. And what we're going to do is we're going to use these bar graphs to keep track of the amount of energy and the types of energy that are located at each of these points. Now, this is going to be purely conceptual. We're not going to have any math, any numbers that are going to show up at all. All right, purely conceptual. So, we're going to analyze what forms of energy are present at each location. So let's change colors again. Yay. So at part A, we're going to ask ourselves how much energy is present. Well, before you even ask that question, you have to try and ask yourself 2 other questions. One, what is the system that I'm going to be analyzing? And so the system is going to be Snake eyes. All right, snake eyes. So we're going to analyze him. And so we're going to do that. So SE, SE. So at all times, we're going to be analyzing what's happening to snake eyes. That's our system. Just like when we did forces, we said, okay, what are the objects are acting on this? Okay, you know, this is our system. Same idea here. All right. And then, second most important thing is we have to decide where is 0. Because if you remember from my earlier discussion, when you choose and you're looking at gravity, you're saying, well, gravitational potential energy is kind of based on how much energy gravity can unleash. Like if I drop a bowling ball on a vase and it shatters, versus if I just rest a bowling ball in a vase. Well, it's different amounts of energy, and in one case the vase is shattered, and the other it's just angry that it's got a bowling ball on it. And I also talked about the fact that if you're staying on the ground, well, you can't really fall unless you dig a hole, and then you could fall in the hole. And then if you're in the hole, you could dig another hole, and blah, blah, blah. So we have to choose where we're going to call 0. Just like, hey, I'm going to call 0. It doesn't mean this is officially 0, but for this problem, this is our reference point of 0. Okay? So I'm going to choose the ground to be 0. So I put a little dotted line here. Okay, little dotted line. And I write EG equals 0. Because at this location, I'm calling this the ground, so snake eyes will have no gravitational potential energy whatsoever. All right? So now we have to ask ourselves, well, what forms of energy are present? So we kind of have a list of things we ask ourselves from all the ones before. So if we go down our list of possible options, we could say, hey, are any rubber bands involved or springs? Is anything stretched or compressed? No. Okay, so no elastic. And then is there anything moving in the first one here? No, he's not moving. He's just sitting on his butt. Okay, velocity is 0, just resting there. Okay, so he has no kinetic. So then we can say, okay, could he fall? Could he fall at all? No, he can't fall. Okay, he can't fall. So then basically he has no energy. So at this location, he has no energy whatsoever because he's just sitting there. Very boring, not a fun action figure. Okay, well, let's look at part B. Well, at part B, he's not moving, and none of this are springs going to be involved, so I'm not going to talk about kinetic. I'm sorry, I'm not going to talk about elastic energy. But he can't fall. Oh my gosh, my brain's off. He's not moving. There we go. He's not moving because our velocity is 0, but he does have a height. All right, because he could fall. All right, he has a certain height, so he could fall a distance. So therefore, he does have gravitational potential energy. And that's it. That's all he's got. So here we say, well, I have all this gravitational potential energy. Okay. So I'm just, again, this is a conceptual bar graph. And they're like, well, okay, energy is always conserved. Well, I went from none to something. How did snake that breaks the law that energy is always conserved? So the question is, well, where did he get this energy from? And that goes to our second statement here, that work is the transfer of energy. So, well, if Billy's playing with snake eyes, Billy lifted up snake eyes up to here. So that means that Billy put the energy into snake eyes. If Billy didn't lift him, snake eyes would have never gotten that energy. So here we have work. All right, work is being put into the system by Billy. So if you almost want to think of it like on by notation, you've got work applied to snake eyes by Billy. All right, because he lifted him up. So then this means that the work put into the system is what gave us our gravitational kinetic energy, gravitational potential energy. All right, so it follows along. Now let's look at point C. All right, so now if we look at point C, we can say, well, he is moving because he's got a velocity, so he has some kinetic. Let's choose a different color for kinetic. There we go. So he has some kinetic. All right. And then he also has height. He's still above the ground, so he's got some height. All right. So he also has gravitational. But here's the thing. He's not as high as he used to be. He's not nearly as high as he used to be. So that means he has less gravitational energy than he used to. Plus, he's got two forms of energy. So we're going to kind of break this up. Now, one thing you have to understand about gravitational is it's a linear relationship. So if I were to kind of break this up, it looks like I'm about, I don't know, half the height that I used to be. All right, but just for the sake of argument, I'm going to say that I'm a little bit more than half. Okay, so when I draw my gravitational, I'm going to go a little more than half of what I used to have. And then if I figure out, well, then how much kinetic do I have to have? Well, I have to have the rest in kinetic. I have to have the rest of what's left over in kinetic. And if I took these two bars and I added them together, I would get this bar right here. So if I just randomly put numbers on these, totally random, and I called this like 10, and I was like, well, it's more than half, so let's call this 6. Well, and this would have to be 4, because energy is always conserved. So whatever energy I had here, I have to have the same amount of energy over here. But notice how it's now in different forms. That's okay. Energy can transfer between forms like nobody's business, but it must always be conserved. All right. So now if we look at part D, all right, we are definitely moving because we have velocity. So we have kinetic, but we are now at ground level. Okay, so we are where we called 0. So we have no height whatsoever. My butt is on the ground. Well, I mean Snake Eye's butt's on the ground, whatever. All right. So that means he has no gravitational potential energy. So that means that all of our energy is in kinetic. So he's basically moving as fast as he's ever going to go. All right. So again, if I just randomly chose, like, let's say it's 10, then this would be 10. Then over here, this would have to be 10 as well because energy is always conserved. All right. So this is how we analyze the types of energies present, and we call this an LOL diagram. And we choose our system, choose our 0 line, and then we ask ourselves at each location what forms of energy are present. All right? So that's how we do this. All right, fun times. See you next time. I'll catch you on the flip side. Science!